Hey, this video is going to show you how you can determine the roots of a quadratic function algebraically. How we're going to do this is by three simple steps. Well, I shouldn't say simple, but three steps. We're going to be factoring the quadratic, we're going to set each factor equal to 0, and then we're going to solve for the roots. Sounds easy because we only got 3 steps to do, but there is some tricky stuff in here, so let's get started. Like I said, we're going to be doing 3 different steps. Before we get there, what I want to show is that when you go to solve for roots, there may be some other words that you may come across. So the words roots, X intercepts, and zeros tend to mean the same thing. There are some slight differences in between those words of kind of what they're talking about, very, very specifically. However, we're not going to discuss that in this course. So for right now, I just want you to know that all those 3 things, if you come across them, are going to mean the same thing. So the first thing that we need to do to solve this algebraically is to factor the quadratic. What we also want to talk about is kind of what exactly are we solving for. So when we're determining the roots of a quadratic function, what I have here is my quadratic x squared plus 3x minus 4, and I've attached the graph of what this looks like. What I want us to notice about this quadratic is some of its characteristics. So it opens up, we have a y-intercept at -4, and we have x-intercepts at +1 and at -4. What I'm going to do first is show you how to actually get this quadratic into factored form, and then we're going to look at how that plays into telling us some of the characteristics of this quadratic, and then we'll define what the roots actually are. So let's start by just solving this example. So in order to make an equation, I'm going to make this function x squared plus 3x minus 4 equal to 0. The first thing that we need to do is factor this quadratic. So for trinomial factoring, how I'm going to decide to do this one is that I need to find 2 numbers. Those 2 numbers need to multiply to the c value or the constant. They need to add to the b value or the middle number. What 2 numbers here are going to work? What we'll notice is that 4 and -1 satisfies both of those equations. Because this is a trinomial where the a value is equal to 1, I can actually jump straight to my factors. And what we're going to have here is x plus 4 coming from this number. And my second factor will be x minus 1 coming from this number. And this is still equal to 0. So what I have here is I've now changed this into... So now what I've done is I've changed this quadratic from what's called standard form into what's called factored form. The reason it's called factored form is because you've now written this in factors. Your first factor is x plus 4, your second factor is x minus 1. So whatever is within these brackets is going to be considered a factor. So then let's set each factor equal to 0. Okay, let's do that. So we've got x plus 4 equals 0. What we're going to do is solve for the x value. So x equals -4. Perfect. Here we have a factor of x minus 1. We're going to set that equal to 0. Let's solve for x. We'll add 1 to both sides and we'll get x equals 1. When I look at these 2 numbers, what does that actually tell us about the quadratic or its graph, its equation? What does it tell us about this particular function? Well, when I'm looking at my graph, I noticed that I had x-intercepts at 1 and -4, and those are exactly what my answers are. So when you are finding the roots of a quadratic equation, you're finding the x-intercepts of the graph or the zeros of the graph. When we think about a function, normally how we're used to seeing this is y equals x squared plus 3x minus 4. We have a certain input for x, and it gives us an output of y. What we've essentially done here is we're going to say, okay, well, what happens when y is equal to 0? Well, remember what the definition of x-intercepts are. X-intercepts occur when y is equal to 0. Y is equal to 0 at both of those points. So it makes sense that when we replace this y value that we're used to seeing here with 0, that we can then solve for the x values. In this case, how we do it is by factoring. Let's try a couple more examples. Here are my three examples. What we're going to start with is x squared minus x minus 6 is equal to 0. First thing we need to do is factor this quadratic. So I'm going to find two numbers that multiply to negative 6. Those same two numbers need to add to negative 1. Again, they should always multiply to the c value and they should add to the b value. So the two numbers that will work here are negative 6 and positive 1. Because this is a trinomial where the a value is equal to 1, I can immediately go to my factors. My first factor is going to be x minus 6. My second factor is going to be x plus 1. And this is still equal to 0. It's really important that if you have this equals 0 that you keep pulling that down as you are solving the equation. The next thing that we're going to do is take each factor and set that equal to 0 separately. So we have x minus 6 equals 0. And our second factor is going to be x plus 1 equals 0. The reason that we are doing this, why are we setting this equal to 0? Well, remember what these two things are. Factors are just fancy ways of writing numbers. So we have a number multiplied by another number, and that gives us 0. Well, what we know is if I had, let's say, x is equal to 6. Well, when x is equal to 6, what I notice is that if I had 6 minus 6, I get 0. 0 times anything is 0. So what you're really trying to figure out is what numbers can I input for x so that one of the factors becomes 0, because 0 times anything is equal to 0. Like in the example I was saying, if x is equal to 6, well, 6 plus 1 is 7, but it doesn't matter what the second factor is. 7 times 0 is just going to be 0. So this is why we're taking each factor separately and solving for when would x make this equation equal to 0. So for my first one, x minus 6 equals 0, we'll add 6 to both sides and we're going to get x equals 6. For the second one, we'll subtract 1 from both sides and we'll get x equals negative 1. So what this means is that these are the roots. If you had a graph in front of you, if you put this into a graphing calculator or onto some type of graphing technology, what you're going to notice is that when this quadratic graphs, it's going to look something like this. It's going to open up and you're going to have an x-intercept here at negative 1 and you'll have an x-intercept here at 6. So now there's an algebraic way of finding the x-intercepts. Let's try one more example. Same thing, where we're going to start, we need to find two numbers that multiply to the c value, which is 2. Those same two numbers need to add to the middle value, which is 3. The two numbers that will work here are 2 and 1. Again, this is a trinomial where the a value is equal to 1, so we can immediately just go straight to our factors. So we're going to have p plus 2, p plus 1, is equal to 0. Again, I'm adding that equals 0 in. That's super important to have there just to make sure that it's staying as an equation. Next, we're going to take our factors and set them equal to 0 separately. And then we'll solve for p. So subtract 2 from both sides, we get p equals negative 2. Subtract 1 from both sides on the next one, we get p equals negative 1. And there are the two roots. Let's try one more example. Here what we have is r squared minus 4r equals 12. Here's where we want to be really careful. Did you notice that the two examples that I had before both were equal to 0? This is actually super key in when we're trying to factor. Unless I have everything on the same side of the equal sign, this doesn't quite work. What you may notice is that some people will try to factor out an r here and then they try to get it to equal 12 and it doesn't really work. The whole concept or why this works so well is that we get this thing that is equal to 0. And then we can use that 0 property that I was talking about before. So first thing is, unless you have it set in standard form, you're not able to factor it. So we're going to get this in standard form by subtracting 12 from both sides, which brings a negative 12 on the left side, and then the right side is equal to 0. First, let's find two numbers. They need to multiply to negative 12, and they need to add to negative 4. What two numbers will work here? Here, negative 6 and positive 2 will work. Because I have an a value that's equal to 1, I can immediately jump to my factors. My first factor will be r minus 6. My second factor will be r plus 2. and this is equal to 0. Let's take each of our factors and set it equal to 0 separately. So we have r minus 6 equals 0, and r plus 2 equals 0. Solving for each of these, we're going to add 6 on both sides for the first one, which would give us r equals 6. And I'm going to subtract 2 from the next one, which will give me r equals negative 2. Let's try a few examples of difference of squares. All right, here is our difference of squares. So what we're going to start with is by factoring these. I've shown 2 different ways in a previous video of mine, and I will link it here just so that you can see how to factor a difference of squares. The way that I'm going to use it is by taking the square root. So the first thing that I'm going to do is square root both terms. So I'll square root x squared, which gives me x, and I'll square root 25, which equals 5. A difference of squares will always have 2 factors that are very similar. One will have subtraction and one will have addition. So the first one we can have is x minus 5. The second one would then be x plus 5. And we're going to set that equal to 0. Next, we're going to follow the next steps just like we did before. We're going to take each factor and set it equal to 0 separately. And then here for the first one, add 5 to both sides. We get x equals 5. Subtract 5 from both sides for the next one, and we get x equals negative 5. Another way of solving this is just by trying to get x by itself. So if we have x squared minus 25 equals 0, another way that we can do this is by adding 25 to both sides, which gives us x squared equals 25. And then we can square root both sides. Where we have to be really careful is that when we square root both sides, what we have to remember is that x could actually be positive or negative, because a positive number squared is positive and a negative number squared is also positive. So when you go to take the square root, you also have to remember that you're going to have a principal square root and a secondary square root. So you'll have to look at plus or minus 5, which is going to compensate for those 2 answers that we had previously. Let's try one more. So we have 9x squared minus 4 equals 0. First, let's take the square root. So the square root of 9x squared is 3x. The square root of 4 is equal to 2. Next, we're going to write our factors. One will be subtraction, so we'll have 3x minus 2. The other one will be addition, so we'll have 3x plus 2. And this is equal to 0. We're going to take each factor and set it equal to 0 separately. Okay, for the first one, 3x minus 2 equals 0. How I get x by itself? I'm going to add 2 to both sides. That eliminates the 2 from the right, and we get positive 2 on the right side. Then I'm going to divide both sides by 3. That's going to eliminate the 3 from the left. And on the right side, I get 2 divided by 3, which is just 2/3. I'm going to leave it in fraction form. The next one, first I would do is subtract by 2. So I'll get 3x equals negative 2. And then the next step, just like before, I'm going to divide both sides by 3, and we'll get x equals negative 2/3. Again, I'm going to keep this in fraction form. How we would solve it the other way is trying to get x by itself. So starting with 9x squared minus 4 equals 0, first thing I'm going to do is add 4 to both sides. That will give me 9x squared on the right, on the left side, and 4 on the right. Next, let's divide both sides by 9, and I get x squared equals 4 over 9. Just like before, I need to take the square root of both sides, but what I need to remember is that when I take the square root, I need to consider both the positive and the negative answer. So on the left side, I get x. But on the right side, I have to take the square root of both the numerator and the denominator and consider the fact that it's going to be positive and negative. So the square root of positive 4 is 2, and the square root of 9 is 3. And what we get there is x equals positive or negative 2/3, which is exactly what we got last time. Either one of these strategies works. What I find is that when I teach this method here, the one that I have on the bottom, people tend to forget about the fact that you have to have a positive and a negative answer, whereas it doesn't get forgotten as much when doing the strategy on top. Either one of them works. I just find that there's more errors in the second one, but totally up to you which one you use. I hope this video helps. Have a good day. Bye.